Hello, Mr. Kaczynski here. Section T of IXL's 8th grade math. In this video, we're going to do area between two shapes. Simple concept. The last one is pretty tricky though. I've just got 4 examples, so stick around for that last one. All right, what's the area of the shaded region? So this yellow region right here. All right, well, let's find the area of the large square there first, okay? So that's going to be 25 squared, which is 625. Get to that in a second. But what about this blue outlined square here? It's got an area of 7 squared. 7 times 7 is 49. And what are we going to do with those? We're going to subtract one from the other. It's like we've got this big square and we're cutting a hole out of it, so we're taking away some of its area. All right, so like I said, 625 minus 49. All right, so 625 minus 49 is 576. 576 square kilometers, or kilometers squared. Also, well, I'll show you that in a second. All right, so now we've got a couple of triangles. Well, it really doesn't change anything. We've got a triangle that is 35 by 34 or 34 by 35. So to find its area, we do 1/2 base times height. So 1/2 34 times 35. And then we'll subtract the area of that triangle that's inside of it. So that would be 1/2 times 20 times 22. And if you got a decent scientific calculator, you can cut some work out here. And that's what I'm going to do right now. I'll do 0.5 times 34 times 35 minus 0.5 times 20 times 22. So we don't have to show everything to get that the answer is 375. 375 square meters. All right, and then we get into circles, which are probably the sticking point for a lot of people when they work on this. All right, what's the area of the shaded region? So we want to do the area of the whole thing, but we don't even know its radius. It's 8 from here to here, but we need to know the radius from the center all the way out, because the area of a circle is pi r squared. So how about we figure that out first? You know, what is this distance right here? Well, if the diameter is 32, then that of the orange circle, I guess we'd call that, then this is 16 kilometers. It's half of the diameter. All right, now we can do this. All right, let's take the purple one, so pi r squared, and they want us to use 3.14 for pi in this. So we're using 3.14 times 24, which is 16 plus the 8 squared. And then we're going to subtract from that the area of this smaller circle that's inside it. So that would be pi 3.14 times radius 16 squared. All right, let's grab the calculator and let's type it in. So 3.14 times 16 plus 8, which we know is 24. Save ourselves a little bit of time. Squared minus 3.14 times 16 squared. 1004.8. 1004.8. And that is kilometers squared. All right, and this is the toughest one I can find for you in there. They don't even give us the diameter of that inner circle. They only give us the circumference. But circumference is pi times d. Circumference is pi times d. All right. So let's do 25.12 equals 3.14 times the diameter. All right, so if we just divide both sides by 3.14, we'll then know the diameter. So 25.12 divided by 3.14 is 8. That's a nice clean number. So now we know that the diameter is 8. Okay, that means that the radius is 4 of the inner circle. So now we can set it up exactly like we did the last one. Here we go. Pi r squared for the area of the bigger circle. So pi is 3.14 or about 3.14. The radius is the 4 plus the 2. And then we're going to subtract from that the area of the smaller circle, pi r squared, 3.14 times 4 squared. Again, let's grab our calculator and do that. 3.14. 4 plus 2 is 6 squared minus 3.14 times 4 squared. $62.8. And again, we're dealing with kilometers, so kilometers squared or square kilometers. All right, so just a bunch of subtraction, basically. And then that last one, we had to find the diameter before we could find the area. So area between two shapes, good luck, and let me know how it goes.